Good evening. Today we are going to see the problem on Thevenin theorem. So, in this Thevenin theorem, we are going to find out the current flowing through the RL if the RL value is 3 ohm. Okay. In the first step, we have to find out Thevenin equivalent voltage source. And the second step, we have to find out the Thevenin equivalent resistance. In the third step, we are going to find out the current flowing through the RL. Okay, so the first step, whatever I said, your first step is to find VTH, that is Thevenin equivalent voltage. How we are going to find out means, okay, first we have to remove the branch which we want to find out the current. That is, we have to remove the RL. Okay, so I am drawing the circuit without RL now. A voltage source and a 2 ohm resistance and a 4 ohm resistance and a 2 ohm resistance. So this is our circuit without. I am replacing the values 2 ohm, 4 ohm, 2 ohm. This is 15 volts. Clear? By seeing this circuit, if we can say this branch is a redundant. Redundant means if a branch which is series with the open circuit is a redundant, so it won't take any current. So that I am removing this 2 ohm resistance by redrawing the circuit without considering the 2 ohm, that is redundant branch, so that we will get a circuit in this way. Okay, so if I remove this 2 ohm resistance, we will get a circuit. This is your VTH. Okay, our objective is to find out this voltage across this one. So I am replacing the values 15 volts, 2 ohms and a 4 ohms. As you can see that in parallel voltage will be the same. So if you know the voltage across 4 ohm, the same voltage will be in the VTH. So to find out the voltage across this 4 ohm, first I need to find out the current flowing through 4 ohm. As you know that I is equals to V by R. In this case, we have a 2 resistance which are connected in series fashion. Okay, so that it will becomes as a V by R1 plus R2. So the value of 2 resistance is 2 ohm and 4 ohm. We will get 15 divided by 2 plus 4. We will get how much? 15 divided by 6. That is 2.6. 15 divided by 6. 15 divided by 6. So the 15 by 6 value is, it is 2.5 amperes. Okay, so the current flowing through the 4 ohm resistance is 2.5 ampere. But our objective is to not find out the current flowing through 4 ohm. Our objective is to find out the voltage across 4 ohm. As you know that from the Ohm's law, V equals to I into R. So the current flowing through the 4 ohm resistance is 2.5 and the resistance is 4. So by 2.4 times of 4 is, which will give the 10 volts. So the value of VTH is 10 volts. Okay. So in this way, we are going to find out the VTH. Okay. In the second step, we are going to calculate the R equivalent. How we are going to find out? In the same way, that is, first we have to remove the branch which we want to find out the current. So the first step is remove the branch which we want to find out the current. So I am removing that branch, that is RL. Okay. So according to your first step, I am remove the RL. The second step is we have to replace all the sources with their internal impedances. If you know the internal impedance, we can replace with that. If you don't know the internal impedance, all the voltage sources are replaced with short circuit. All the current sources are replaced with open circuit. In this case, we have a voltage source, so we have to replace with short circuit. So I am replacing with the short circuit. I am drawing the circuit. So I am replacing the voltage source with a short circuit and a resistance of 2 ohm and resistance of 4 ohm and a resistance of 2 ohm. Okay, so this is your equivalent circuit. Clear? So if you find out the equivalent resistance across this T in this open circuit, we will get the R equivalent. I am placing the values 2 ohm, 4 ohm and 2 ohm. By seeing this circuit, these two are in parallel. Okay, 2 ohm and 4 ohm is in parallel, and that this 2 ohm is series. So I'm writing R equivalent is equals to, with reference to these two terminals. So 2 ohm and a 4 ohm both are in parallel. That is, as we know that if the value of two resistors are in parallel, the formula will be R1 into R2 by R1 plus R2. Okay. So if I take the 2 ohm and the 4 ohm are the two resistances, and this value of series resistance. So these two combination will series for the 2 ohm resistance. So this is 2. Clear? So I'm replacing the values of R1 and R2. That is 2 into 4 by 2 plus 4 plus 2. So we'll get 8 divided by 6 plus 2. It will give 8 divided by 6 as 1.33 plus 2. So obviously you will get 3 ohms. So this is the equivalent resistance for a Thevenin circuit. But our objective is to find out the current flowing through the RL when the RL value is 3 ohm. So the final step when it comes to step 3. Okay, final step is to find IL, that is current flowing through R equivalent. I am drawing a Thevenin equivalent circuit. Let's say VTH and a R equivalent and then RL. Okay, so this is your VTH, this is your R equivalent, and this is your RL. Okay, so as we know that the value of VTH is 10 volts, the value of R equivalent is 3.33 ohms, and the value of RL is 3 ohms. Okay, so this is single circuit. All are connected in, these two resistors are connected in series. So we'll get IL as VTH by R equivalent plus RL. So I am replacing all the values. 10 divided by 3.33 plus 3, that is 10 divided by 6.33. We'll get the value as it is 1.57 amperes. So in this way we are going to solve the problems on Thevenin theorem. Thank you so much. Have a great day.